and we are going to hand it over to our last speed talk of the day, which is from Timothy Keitt. And he is going to be sharing a little bit about BioSense, which is a low-cost and fully programmable automated sensing platform. Whenever you're ready, Tim.
Thanks. Yeah. Thanks for the invitation. So this work we've been doing for a number of years, and it was motivated by, as you all are really familiar with, the rapid pace of change in the environment and the limitations and how much we can spend, in the field monitoring and collecting data. So this is to augment field studies. And so we proposed kind of a model. You could read a little bit more about this in the science paper, but the idea that we would build devices that are, connected, have communications, potentially can inform in near real time, have intelligence embedded at different levels throughout the kind of setup, potentially, hopefully self-sufficient with, low duty cycles where we don't have to go out constantly to retrieve data, but that they can operate somewhat self-sufficiently and maybe adaptive. This is a sort of high and mighty idea, but we'd like the idea if we could have these devices actually learn to respond to novel inputs over time. And so that's kind of more in the AI research. So we put together this platform, and here's an example. It's basically a Raspberry Pi in a box. And we've been focusing a lot on sound recording because it has a large footprint. You can integrate a lot about the environment in an area by doing sound, whereas, for example, camera trapping and so on has a very narrow focus in the environment, although we're interested in moving into those kinds of things. So we also do microenvironment at the same time. We really want to understand better the relationships between activity and those sorts of microenvironmental things. Here are some of the kinds of sensors that we've been putting on them, and we're interested in expanding that. Deployments. This started out with funding through our field station network in Texas. So we've been deploying there, and we're going to complete this in this year, having these up running on all of our 7 sites within the hill country. Locally, we've done some work with golden cheek warbler in the Balcones Canyonlands, down in South Texas, a popular birding spot where I take students, and so we have some device there. And then we have 4 now out in Tipitini Biodiversity Station in Ecuador. This is me a few weeks ago programming one of the devices 45 meters up in the canopy tower. So we've been recording there. A bunch of lists. And so this is probably unnecessary level of detail, but anyway, we've run into a lot of interesting things as biologists starting to work with all of this electronics. Power supplies are really important, and it's easy to underestimate. Reliable connectivity in the field is hard. I've spent a lot of time working on virtual private networks and things like that, but it's still quite difficult to maintain consistent connectivity, and so there is some intervention needed. Configuration is, vastly easier if you can tap into the box from your laptop. So we've been making access points. The AI, we do BirdNet like everybody, and AI is very complicated, and it gives you a lot of very solid false positives, and we're really working hard on to better ways in which to deal with that kind of data to make good statistical inference. It's been a wonderful project for students involvement, this is a pair of Ecuadorian students that we were working with this past few weeks, learning about the platform, but we've had a lot of computer science and engineering students come into our lab, and that's been really fun. And the other thing is, don't always do it yourself. We've given out a recipe. You can look at the Hardware X paper, which is pretty basic. We've gone way beyond that, but there are, the computer and electrical engineers really do know what they're doing. So we're working with like the robotics labs on campus and stuff like that now to do custom PCBs and things like that. So there's a lot of that you can do yourself, but getting the expertise and interdisciplinary we're going is great. I've written a whole software system for this, and that'll become out open source pretty soon. And so it's a client server setup. I can't go into all of this, but one of the things we do is we record continuously rather than in small bytes, and then we thin the data later intelligently using AI tools, so that we can go for potentially years. And that's my stop. Have these accumulate data for a very long period of time. So anyway, a bunch of people in the lab did great work on this, and we've had some various kinds of funding, and I'd be happy to take any questions. Thanks.
Thank you so much. I have a question. So it seems like this is pretty like a pretty customizable tool. Are there any, I guess, are people already using it in the field? And if so, has there been any like applications or customizations that you've been like surprised by or excited about to see in the future?
Well, so far it's been just us in a sense. I mean, I think other people are doing sort of pie-based, things like this as well as our group. So there are a lot of interesting applications out there. Amongst us, I think we've been doing some soil temperature and moisture probes on these devices, and I find that really interesting because we had working with another group that does automated plant and ecosystem exchange, so more carbon and water balance kinds of work. And we worked with one of their grad students, and they showed us how we could integrate their kinds of, like, they do sap flow monitoring and a bunch of things. And so we're very keen on the idea that the ecosystem properties are very relevant to our understanding of, say, wildlife activity, biodiversity, and so on.
Amazing. Well, thank you so much. And I definitely encourage you if there are any other like issues or challenge, all those issues and challenges that you had on the previous slide about AI and hardware integration and whatnot. I feel like you're in good company, and definitely encourage you and anybody else who's having issues facing challenges in their research to post about it on Wild Labs. It's a great place to commiserate and find solutions, and connect with other folks. But thank you so much, Tim.